Hi, welcome to Educators. In this video, we are going to see different types of matrices like square, symmetric matrix, triangular matrices, identity matrix, and orthogonal matrices. For the mathematical approach, you can watch Dr. R.K. Educational and Guidance. In this video, we are going to see different types of matrices in Python. First, we'll see a square matrix. A square matrix is a matrix where the number of rows is equivalent to the number of columns. Now, how to define a matrix in Python? Here, I have imported an array from NumPy, and if you print this, you can get a matrix 1, 2, 3, 3, 4, 5 and 3, 5, 6. This matrix is a square matrix. Now, coming to a symmetric matrix. A symmetric matrix is a type of square matrix where the top right triangle is same as the bottom left triangle. Now, if we look here, this matrix is a 3 by 3 matrix and it is also a symmetric matrix. If you look into the output here, this is having the same values in the upper triangle and also the lower triangle of a given matrix. The next matrix is a triangular matrix. A triangular matrix is also a square matrix that has the values in the upper right or the lower left of the matrix with the remaining elements filled with zeros. If you look into this example here, this matrix, both the matrices M here, what I have mentioned here, both are lower triangular matrix with the values on the lower end of the triangle and the remaining part is filled with zeros. NumPy provides functions to calculate the triangular matrix from an existing square matrix. Now we'll see the functions provided by the NumPy. For that, I'm just copying the code which is defined above. For this, I'm going to import from NumPy I'm going to import a function TRIL. From NumPy import TRIU. TRIL is a lower triangular matrix and here TRIU is the upper triangular matrix. Now, we can see how to find the lower triangular matrix from a given matrix. We have defined a matrix M. From this matrix, how to calculate the lower triangle and the upper triangle. Now, we'll go with lower triangular matrix. L is equal to TRIL of the matrix. Print L. Next, U is equal to TRIU of M. Print U. If you run this, you can see a lower triangular matrix and an upper triangular matrix. So, Python provides functions to calculate the triangular matrix from an existing matrix. The next matrix we are going to see is a diagonal matrix. Diagonal matrix is one where the values outside the main diagonal have 0, where the main diagonal is taken from the top left of the matrix to the bottom right. Now for this, if you look at the code, NumPy provides a function diag that can create a diagonal matrix from an existing matrix. Now if you look into this, I am going to import from NumPy import diag, D-I-A-G, and after defining a square matrix, we are going to calculate the diagonal matrix. Or first we'll extract the diagonal vector and then we'll create a diagonal matrix from the vector. For that, I am taking D is equal to DIAG of M. Print D. D is equal to DIAG of D. Now if you run this, you can see here, this is a matrix which we have defined, M matrix, and 1, 4, 6 is a vector. Now D is equal to DIAG of M. Here we are going to extract a diagonal vector. From this diagonal vector, we are going to create a matrix. So what is that matrix? This is the matrix. So we got the diagonal elements, the remaining all are filled with zeros. So here diagonal is a function provided in NumPy. Next is identity matrix. An identity matrix is a square matrix that does not change a vector when multiplied. In NumPy, an identity matrix can be created with a specific size using identity function. So for that, from NumPy, import identity. I is equal to of 3. Print I. If you run here, you can see an identity matrix. So this is how we can create an identity matrix. Here in the identity matrix, we are going to pass the size. Based on the size, the output will be generated. Now if you are going to mention here 4. Now if you run this, you can see an identity matrix of size 4 by 4. The next is about orthogonal matrix. Coming to this, two vectors are orthogonal when their dot product equals 0. The orthogonal matrix is defined formally as Q transpose into Q is equal to Q into Q transpose, which is equal to an identity matrix. Now we'll see this orthogonal matrix. For that, you need to import NumPy, import array from NumPy dot lialg import inv. Inv is the function to give the inverse equivalence. Now I'm going to define an orthogonal matrix. So I'm just representing it with Q. Q is equal to array of, I'm going to take 1, 0, 0, -1. Now print Q. Now if you run this, this is an orthogonal matrix, and now I am going to find the inverse equivalent of this. So V is equal to INV is a function which is used to calculate the inverse. INV of Q. Right. Next, I am going to print Q transpose. How to calculate a transpose? The matrix dot T gives you a transpose of a matrix. Now I am going to print V. Next, we need to calculate the identity equivalence. For that, I is equal to, here it is given, Q into Q transpose, Q into Q transpose. So, Q into Q dot of Q transpose. It's a multiplication, Q into Q transpose. It is matrix multiplication. It is not an element wise multiplication. If it is an element wise element multiplication, we could have taken Q into Q transpose, that is star operator. But it is matrix multiplication. We need to make use of Q dot of Q into T. For this information, you can watch our previous video. Now if you run this, we can see a matrix inverse, and I am just printing V inverse of it. Yes, here I have performed identity, but I didn't print it. Now I will take print of I. Now if you run this, you can get an identity matrix. Now by this we can say that it is an orthogonal matrix. Q transpose into Q is equal to Q into Q transpose, which is equal to an identity matrix. This is all about the types of matrices. Thank you for watching.